But before we do any word problems, let's just go through this. If we are saying a house can be painted in 6 days, how much of the house, if we had to write a ratio, how much of the house would be painted after one day? Violet? Yeah, 1/6 of the house would be painted in one day. How much of the house would be painted in 2 days? 2/6 or 1/3. I'm going to keep it as the 2/6, but you're right, that is 1/3. How much of the house will be painted after X days? X over 6. You got it. And how much of the house would be painted after 6 days? 6 out of 6, which is 1 whole. So when a job is completed, when a job is fully completed, it will always equal 1. When a job is fully completed, it will always equal 1 for the days worked out of the days total. And I gave you some little helpful hints here. Our total job equals 1, and that makes sense based on what we just said, right? The days completed out of the total days it takes, or the total time it takes, that will always equal 1. Okay, so now when multiple people are working together, just keep this in mind and then we'll see how it works. The numerator will always assign as the time it takes for them to do the job together, and the denominator will be their individual times. So when we're solving these work problems, the numerator will always be the time it takes for them to do the job together. The denominator will be their individual time. So let's just jump right into a word problem. So it says James and Kenny mow the lawns on their block. James can do the job in 12 hours alone, and Kenny takes 24 hours in total to complete the job by himself. If they work together, how long will it take them to mow all of the lawns on the block? All right, well, do we agree that James plus Kenny will equal the total time or the total job? So since this is a group work problem, I'm going to make two fractions. The numerator is going to be their time together. The denominator is their individual time. And that's going to equal the total job. And we know the total job has to be 1. Do we know how long their time together is? No, that's the unknown. So I'm going to let X equal time together. And the numerator is their time together. So I'm going to put an X and an X in both numerators. And then how long does it take James to do the job by himself? 12 hours. So that's the first denominator. How long does it take Kenny to do the job by himself? 24 hours. And now we have our equation to solve, and it's a fractional equation. When we have a fractional equation, what do we want to do to solve, Lily? You got it. We want to eliminate the denominator. So we're going to multiply everything by what would be the common denominator. And what would be the common denominator here? 24. So 12 goes into 24 twice. 24 and 24 cancel. So we're going to be left with a 2x plus x equals 24. 3x equals 24, so x will equal 8. So how long would it take for them to do the job together? 8 hours is our answer. Yes. Number and label's enough for me. All right, next one. It says Barbara takes 6 hours to clean her room. Clearly, it's a very messy room. If her brother helped her, it would only take 4 hours. How long would it take her brother to clean the room all by himself? All right, so again, this is a work problem. They're working together. So we're going to talk about Barbara plus her brother. So I'll say B plus bro equals the total job. So we have a fraction for Barbara, we have a fraction for her brother. The total job is 1. So it says Barbara takes 6 hours to clean her room. Do we agree that's her alone time? Where are we putting her alone time? In the numerator or the denominator? Denominator. So her alone time is in the denominator. If her brother helped her, it would only take 4 hours. Where is that 4 hours going? The numerator, that's their time together. Do we also agree for the brother, the numerator is 4? But do we know the brother's time alone? No, that's what we're trying to find. So we're going to let X equal brother time. I can simplify 4, 6, right? It's a fraction, I can simplify it. So if you want, you can simplify it. If you want to leave it like this, you can leave it like this. If I chose to leave it like this, is it such a big number that it would make it so much more difficult for me? Not really. So we can just leave it and multiply everything by 6. Oh, sorry, not 6. 6 what? 6x, you got it. So here the 6's cancel. Here the x's cancel. So we're going to be left with 4x plus 24 equals 6x. So when we solve this, we are going to get 24 equals 2x, so x will equal 12. What does this represent? Violet? Yep, this is his time alone. So it's going to be 12 hours is the answer. Can I keep going? Okay, so now we have more people. Ned, Ethan, Jim, and Bill are loading a truck to make deliveries to upstate New York. Alone, it would take them 10, 16, 15, and 12 hours respectively. What do I mean when I say respectively? Good. In the order that the names were given is the order that the hours they worked. If they work together and begin loading the truck at 10 a.m., when will the truck be ready to make deliveries? All right, since this is a work problem, I know that Ned plus Ethan plus Jim plus Bill will equal the total job. So I'm having a fraction for each of them, and the total job equals 1. So I know their individual times, right? Their individual times 10, 16, 15, 12. Where do I put all of those individual times? In the denominator. So we are 10, 16, 15, 12. Do we know their time together? No. So I'm going to let X equal time together. So we have X, 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 and X. So we now need to eliminate this denominator. Our LCD is a big number. It's going to be 240. So now we cross simplify, and I'm going to get 10. Oops, fix this. 10 goes into 240 24 times. 16 goes into 240 15 times. 15 goes into 240 16 times. and 12 goes into 240 20 times. So we are going to be left, I'm going to bring it up here, with 24x plus 15x plus 16x plus 20x equals 240. So we will have 75x equals 240. When you divide this, it's not going to go in evenly. When you divide this, you're going to get a 3.2. What does this 3.2 represent? Ariana? Good. So it would take them 3.2 hours to load the truck if they were working together. Did I ask how many hours will it take them to load the truck? No, go back. When will the truck be ready to make deliveries if they started at 10 a.m.? So what do I want? Yeah, I want a time. But the problem is, we know this is 3 hours, right? And then it's 0.2 of an hour. What do I have to do with that 0.2 of an hour? What do I have to convert that to? We have to convert it to minutes. So do we agree that 0.2 of an hour is the same as 2/10 of an hour? 0.2 is 2/10. And an hour is how many minutes? 60. So what you're going to do is you're going to multiply your fraction by 60. So it's 2/10 times 60, which is the same as 1/5 times 60. And what is that? 12 minutes. So how long did it take them to load the truck? 3 hours and 12 minutes. So now we're going to have 10 a.m. plus 3 hours and 12 minutes. What time does that bring us to? 1:12 p.m. Okay, next one. Ned can mow a lawn in 75 minutes. Pedro can do it in 50 minutes. If Pedro watched Ned mow for 20 minutes, then helped to finish the job, find the total amount of time for the job. All right, so this is a little bit more complicated. So Ned can mow a lawn in 75 minutes. Pedro can do it in 50. So do we agree that it's still Ned plus Pedro will equal the total job? We're good with that? Okay. So fraction plus fraction equals one whole job completed. And we know their individual times, right? Ned's individual time is 75. Pedro's individual time is 50. Okay. Now, it's saying if Pedro watched Ned mow the lawn for 20 minutes, then helps to finish the job. So if Pedro was watching Ned, who was during their time together, who was actually working longer? Ned was working longer. Ned was working longer for how many minutes? 20. So what I'm going to do is I'm going to let X equal time together. And Pedro, it's safe. He didn't do any extra work, right? So his numerator is X because he joined in and then they finished the job together. But Ned, during their time together, was still working extra than Pedro. How many minutes extra? 20. So how am I going to represent that? No, x plus 20. Nope, 75 minutes, 50 minutes, right?
Oh, okay.
Very good. I see what you were thinking, though. That's good that you thought ahead like that, but no, this was all in the same units. Okay, and now we just solve. So we're going to eliminate this denominator. I'm going to multiply by 150. No, 150, no. Yeah, 150. Okay. I'm going to multiply by 150. So we're going to end up with 2 times the quantity of x plus 20 plus 3x equals 150. So distributing that too. So we have 2x plus 40 plus 3x equals 150. If you solve this, you're going to get x equals 22. What does x represent? Besides Ariana, what does x represent? Good. X represents their time together. But then go back to what we were find the total time for the job. Was the total time for the job just their time together? No, because Ned picked up the slack and worked for how long by himself? 1 minute. So what do we have to do to find the total time for the job? You got it. So the total time is going to be 22 plus 20, which is going to be 42 minutes. All right, next one. Work crews A, B, and C can pave a road in 10 days if they work together. If they work alone, crew A would take 60 days to do the job. Crew B would take 3 times as long as crew C to do the job. How long will it take the crews B and C to each work alone? All right, so I know it's going to be A plus B plus C equals the total job. So we have our 3 fractions equaling our total job, which is 1. So it says work crews A, B, and C can pave a road in 10 days if they work together. So what are all my numerators? 10. If they work alone, crew A would take 60 days. So right there, 60. And then it says crew B would take 3 times as long as crew C to do the job. So since crew B would take 3 times as long as crew C, do we agree that crew C is shorter time? So I'm going to let X equal crew C time. So then B would be 3 times that, which is going to be 3X. I'm going to simplify the 10 over 60. What do you think I'm going to simplify that down to? 1/6. You got it. So now we need to multiply by a common denominator. What would be that common denominator? Not 2x, no. 6x, you got it. So we're going to multiply everything by 6x. Goes into 6x. twice. Okay, so we're going to be left with, bring it up here, x plus 20 plus 60 equals 6x. So x plus 80 equals 6x. 80 equals 5x, so x will equal 16. So go back. What is it asking? How long will it take crew B and crew C to each work alone? Well, we said X was which one, crew B or crew C? Crew C. So we know crew C is, are these days. So crew C is 16 days. What about crew B? 3 times 16, which is 48. You got it. So I still have students that need to take it. I think the last student that's going to take it is Friday. So that means next week I can give them back to you. All right, number 5. It says Tammy is filling her pool with 2 hoses. The larger hose can fill the pool by itself in 10 hours. The smaller hose can fill the pool in 15 hours. Tammy left the drain open in the pool and it can drain the pool in 20 hours. How long will it take before the pool is filled with both of the hoses running and the drain open? Okay, so now I'm adding a third element in here. This is still a work problem and the 2 hoses are working together. So their efforts are being added together, but there's something going against the hose. What's going against the hoses? The drain. What is the drain doing? Is it helping them? Is it adding to their work effort or is it taking away from their work effort? It's taking away. So we're going to add the 2 hoses, but then we have to subtract the drain. So we're going to add the 2 hoses, but then we have to subtract the drain. So it's going to be hose 1 plus the second hose minus the drain equals the total job. Okay, the larger pool can fill the hose by itself in 10 hours. 10, numerator or denominator? Denominator. The smaller hose can fill the pool in 15 hours. Again, denominator. Tammy left the drain open in the pool and it can drain the pool by itself in 20 hours, third denominator. Do we know the time of the working together? No. So we're going to let X equal time together. So all of these numerators are X. So if you solve this, I don't think we need to keep going through the solving portion of it. If we solve this, we're going to get X equals 60 over 7. And because it says how long will it take before the pool is filled with both the hoses running and the drain is open, I'm looking for the time. If you were to just say 60 over 7 hours, I would take it. I'm okay with that. It's a time. If you wanted to change this to a mixed number, you'd get 8 and 4/7 hours. I would also take that. I would not try to change this into minutes. The only time you would change that fraction or decimal into minutes is if I were asking what? Ariana? At what time? Okay, not how long. All right, next one. If 3 pipes are all open, they can empty a pool in 3 hours. The largest pipe alone takes 1/3 the time the smallest pipe takes, and half the time the other pipes take. How long would it take each pipe to fill the pool by itself? I don't want to deal with fractions. So when it says, or any additional fractions if I don't have to. So when it says the largest pipe alone takes 1/3 the smallest pipe, we can say the smallest pipe is what to the largest pipe? Good. So I'm going to look at it as the smallest equals smallest is 3 times largest. So in that scenario, I'll let X equal what? Ariana? The largest. So we have how many pipes? 3 equals our total job. So if 3 pipes are all open, they can empty a pool in 3 hours. Where is that 3 going? If 3 pipes are all open, they can fill an empty pool in 3 hours. Or they can empty, sorry, fill, yeah, all in the numerators. The largest pipe takes 1/3 the time of the smallest. So we said the largest, oh, sorry, we got to say what we're doing. So we'll do, you want to do small plus medium plus large? Okay, so we said the largest is X. So then it says, so then the smallest has to be 3X. And the time the smallest pipe takes and half the time the other pipe takes. So what does that mean? The medium pipe has to be 2X. You got it. If you solve this, we are going to get X is equal to 11/2 hours. If you change this to a decimal, that is 5.5 hours. Would I accept 11/2? Absolutely, I'd accept 11/2. But now let's go back and see what we were asking. How long would it take each pipe to fill the pool? So who's the 5.5 hours? Charlie? Good, the largest. So we know the largest equals 5.5 hours. So then we're going to have the medium is going to be 2 times 5.5, which is 11. And the small is going to be 3 times 5.5, which is going to be 16.5 hours. These aren't so bad, right? So now we're going to talk about motion problems. I think we've done motion problems before. Okay, so what is the distance formula? If you guys remember, I think we talked about this. Distance equals the rate times the time. Yes, D equals R times T, where R is the rate and T is the time. So now if we were going to take D equals R times T and we were going to solve for R, what would R equal? You got it. If we were to take D equals R times T and solve for R, R would equal D over T. And if we were to solve for T, we'd get T equals D over R. Okay, let's do a problem. So it says the Peng family drove from their home into the country at a speed of 80 kilometers per hour. They returned over the same road at 70 kilometers per hour. Why is it important to know that they returned over the same road? Because that tells us what? It's the same distance. They didn't take a detour. They didn't take an alternate route that added mileage. Right. If the round trip took 6 hours, how far did the Pengs drive into the country? Okay. So I'm going to set up a chart. And we're going to the country. And then we're going back home. And here they're saying the round trip took 6 hours. So what do I have their total? What do I have the total of? Their total what? There and back? Total time, right? I have the total time there and back. So since I have the total time, I'm going to put that time last. And so it's going to be the distance, the rate, and the time. The Peng family drove from their home into the country at a speed of 80 kilometers per hour. Do we know the rate to the country? Yes. So the rate is kilometers per hour and it's 80. They returned over the same road at 70 kilometers per hour. So do we know the rate on the way back? Yes. Okay. They returned over the same road at 70 kilometers per hour. Do we know, it says, how far did the Pengs drive into the country? So do we know the distance? No, but do we know the distance is the same for to the country and the way back from the country? So I'm going to put X for both of them. And now I know my total time, right? I know my total time to the country and back. But do I know my individual times? No. But according to our formula, if I have the distance and the rate, can I make an equation for that for the time? So T is going to equal D over R. See, right here, right? T equals D over R. So the time is going to be D over R. So I'm going to have X over 80 and then X over 70. We're going to use our last column to make an equation. So we know time to the country plus time back should equal what? 6 hours. Yep, not 60, 6 hours. So the time to the country is X over 80. The time back is X over 70, and that has to equal 60. If you solve this, you're going to get X is equal to 224. So what does this 224 represent? The distance from this country back to the home and back from the home to the country, from the home to the country. So it says, how far did the Pengs drive only to the country? So only to the country, we drove 224 kilometers. You got it. Ariana? Oh, it's not 60. I don't know why I put a 0 there. It's just 6. No clue why I put 60. All right, number 2. A boat can travel 20 kilometers per hour in still water. It can travel 47 kilometers downstream in the same time that it can travel 33 kilometers upstream. What is the rate of the current? Okay, so let's talk about this. When you're in still water, just think about swimming. Forget about the boat. Think about swimming. When you're in still water, it's basically how fast you're going is what you're capable of, right? That's your rate. Now, if you are going downstream, meaning the water's pushing you along, do you think you're going to go faster when the water's working with you, or do you think you're going to go slower? You're going to go faster when you're going with the current. But what happens if you're trying to swim against the current? You're going to go slower. Same thing with this boat, right? So when it's going downstream, it's working with the current, it's going to go faster. When it's going against the current, it's going to slow it down when we're going upstream. So let's go ahead and make this chart. Let's see. We know it can travel 47 kilometers downstream at the same time. So ultimately, when we make our equation, what do you think we're going to set equal to each other? The times. We're going to set their 2 times equal to each other because it says at the same time that it can travel 33 kilometers upstream. So let's go make our chart. And we're going to have our distance, our rate, and our time. A boat can travel 20 kilometers per hour in still water. So what is that 20 kilometers per hour? Isn't that their base rate without being helped or being like slowed down? Like that's their base rate. It can travel 47 kilometers downstream. So where am I putting that 47? Distance for downstream, 47 kilometers downstream. And the same time that it can travel 33 kilometers upstream. So do we agree that 33 goes for the distance for upstream? Okay. What is the rate of the current? So do we know what the rate of the current is? No. So we're going to let X equal the rate of the current. But our rate is not just the current, right? The rate of the boat is not just the current. The rate of the boat is going to be its baseline rate. And then the current is either going to help it or slow it down, right? So when we're going upstream, is that current going to help it or slow it down? Slow it down. So we're going to do 20 plus X or minus X? Minus X because we're slowing down its rate. For the downstream, is that current going to make it go faster or make it go slower? Faster. So it's going to be 20 plus X. You got it. And don't we know that the time is going to be the distance over the rate? So we're going to have 33 over 20 minus X and then 47 over 20 plus X. Now we have to figure out how to make an equation from this chart. But it says a boat can travel 20 kilometers per hour in still water. It can travel 47 kilometers downstream in the same time that it can travel 33 kilometers upstream. So what should I do with their 2 times? It says in the same time. Set them equal. So we're going to have 33 over 20 minus X is equal to 47 over 20 plus x. Is this a proportion? Yes. How can you solve a proportion? We can do what? Cross multiply. If you solve this, you're going to get x is equal to 3.5 kilometers per hour. It says, what is the rate of the current? We found the rate of the current. Okay, we are done here. These independents you don't have to do, but what I'm going to do in case you want to do them for extra practice, I'm going to give you the answers to them. So for independent number 1, your answer is going to be 1.5 kilometers per hour. For number 2, it's going to be 6 hours. Is that it? Only 2? Okay. That's it. You do have homework tonight. I will post it on Classroom.